Hi, everyone, and welcome to your feedback loops homework. So, a feedback loop is an output of the system is fed back as an input. All right. So, I'm going to try to make this as painless as possible. So, a positive loop, you have to you have to separate the positive and the negative from positive being something good and negative being something bad. It just has to do with the positive and then negative. We're talking about like graphs typically. Okay. So a positive loop is like a runaway cycle. So a change in that direction causes further change in the same direction. Okay. So here, the example that's used is the temperature warms. So sea ice cover melts and it shrinks. Ocean waves then absorb more solar radiation than the highly reflective sea ice, and then temperatures warm, and then more sea ice cover melts and shrinks, and then temperatures warm, and it's this loop of like one thing leading to another, and it gets worse and worse and worse. Okay. Um, so that's your positive loop. It's going in the same direction. Nothing's making it tick back, right? Now, a negative loop is a change in a certain direction leads to a lessening of that change. The big one we use here is your thermostat. Okay, your house is set to, let's say, 70 degrees. What happens is your temperature rises, it gets, well, let's say air conditioning, it gets warmer in there and it kicks on and it brings that temperature back down. Once it gets past this point, it turns off. But naturally, the temperature is going to go up when it's hot out and it reaches this point, it clicks on and it goes back down. So it's going in this direction, in the positive direction, then it's going in the negative, and then it's going in the positive. Something like turns it off and shoves it the other way. Okay. So here, the example is increased carbon dioxide is in the atmosphere. We're using global warming for every single example that we're going to use here. Okay. So increased carbon dioxide in the atmosphere, which is increased greenhouse effect and warmer temperatures, which means there's increased evaporation from the atmosphere. I know it's hard to see with all this stuff here, which means you have increased cloud cover and albedo, which means there's more reflection, which means that the temperatures actually decrease, which is the opposite of global warming. Okay. And then output is back to equilibrium. It's getting warmer, something happens, and then those temperatures start to decrease. Okay. So here's some other long-winded ways or ways of explaining it. So your positive feedback mechanism pushes the system to a new state of equilibrium. Okay. So imagine if you're lost on a high snowy mountain. When your body senses that it's cooling below 37 degrees Celsius, various mechanisms such as shivering help to raise your internal temperature again. But if these are insufficient to restore normal body temperature, your metabolic processes start to slow down. As like most chemical reactions, they happen more slowly at lower temperatures. As a result, you become lethargic and sleepy, and you're moving around less and less, which allows your body to cool even further. Unless you're rescued at this point, your body will reach a new equilibrium, and then you will die of hypothermia. Okay, so we're fun of full of fun examples here. Okay, going to your negative. Okay, this is pushing it back to the original equilibrium. Okay, so imagine you're out walking in the country. As you walk, the sun rises higher in the sky and the air temperature increases. Your body senses that your internal temperature is rising above that 37 degrees, and you start to sweat, which reduces your body temperature by evaporating water from your skin, returning your temperature to normal. Okay, and you live in this example. So, what I'm going to do is here's a little bit about your positive feedback and your negative feedback again. All right. And then some fun facts about global warming, because all of the next examples that we're going to do are about global warming. Okay. So, your fun facts. Your global warming is a natural phenomenon on Earth. If we didn't have it, Earth would have large fluctuations of temperature. Okay. Our atmosphere keeps our temperature pretty steady. Okay. About 80% of our global warming comes from water vapor. Okay, the other 20% are from these greenhouse gases, CO2, CH4, CFCs, N2O, and O3. Okay, O3 is your ozone. Of those anthropogenic greenhouse gases, anthropogenic human caused, okay, 50 to 60% of global warming is from carbon dioxide. Okay, 20% is from methane. Now, oh no. Now here's the thing, ability to absorb heat. If carbon dioxide absorbs like 1, Methane absorbs 20. Methane is a much more potent greenhouse gas. Nitrous oxide is 200, huge, and CFC is 1700 to 700, okay, which is hidden back there. So what we're going to do now is you guys are going to go through, I believe it's 6 different examples, okay? And you're going to have to answer whether they're positive or negative feedback loops. As carbon dioxide levels in the atmosphere rise, temperature of the earth rises. As earth warms, the rate of photosynthesis in plants increase. More carbon dioxide is therefore removed from the atmosphere by plants, reducing the greenhouse effect and reducing global temperatures. Okay, so is this positive? It keeps going, 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 or is this negative where it goes and something kind of ticks it back? Number 2, as Earth warms, the ice cover melts, exposing soil or water. Albedo, which is your reflection, it decreases, which then means more energy is absorbed by Earth's surface, making it warmer, and then more ice melts. Okay, positive or negative? 3, as Earth warms, upper layers of permafrost melt, producing waterlogged soil above frozen ground. Okay, so melted, frozen. So methane gas is released in an anoxic environment. Greenhouse effect is enhanced. Earth warms, melting more permafrost. So is that positive or negative? 4, as Earth warms, organic matter in the soil is decomposed faster. More carbon dioxide is then released. Enhanced greenhouse effect occurs. Earth warms further. Rates of decomposition increase. Okay, so positive or negative for that one? 5, as Earth warms, evaporation increases. Snowfall at high latitudes increases. Ice caps enlarge. More energy is reflected by increased albedo of ice cover. Oops. Earth cools and rates of evaporation fall. Okay, so positive or negative there. And then last one, as Earth warms, the polar ice caps melt, releasing large numbers of icebergs into the oceans. Warm ocean currents, such as the Gulf Stream, are disrupted by additional freshwater input into the ocean. Reduced transfer of energy to poles reduces temperature at high latitudes. Okay, so it gets colder at high latitudes. Ice sheets reform and icebergs retreat. Warm currents are re-established. Okay, so is that one positive or negative? Okay, you guys are probably going to be like, oh my gosh, I don't know, is this graded? I want to see what it is that you guys know and you don't know, if you get the concept of positive and negative feedback loops from this. Okay, thank you.